Welcome to Go Math Lesson 5.5. Today we are looking at determining whether a number is prime or composite. A prime number has only two factors, 1 and the number itself. A composite number is any other number that has more than two factors. We have a couple ways of testing these. The first way is we could make a factor tree like we've been working on. And that way we would take a look at number 18 and we would make a little factor tree for 18 and we would do 1 times 18 and 2 times 9 and 3 times 6. And you can see that this has 2, 4, 6 factors, so we would consider that composite. The other way we could look at that is we could use our divisibility rules. The rule for 2 is that if the number is even, it is divisible by 2. 18 is even, so it is divisible by 2. So right there we would know that it would have more factors than just 1 and itself. The other way we could do it is we could come up with as many pictures as we could draw or arrays that give us 18. We could do a 1 by 18 array. We could do a 2 by 9 array. Or we could do a 3 by 6 array. And since we could do all those different arrays, we would know that that's a composite number. Let's look at 49. Let's use the divisibility rule method. It is not divisible by 2 because it is not an even number. It is, if we want to check for 3, we would do 4 plus 9 equals 13. 13 is not divisible by 3. So it's not divisible by 3. It is not divisible by 4 because the closest multiple of 4 would be 48. It is not divisible by 5 because it does not end in 0 or 5. It is not divisible by 6 because it is not divisible by 2 or 3. But it is divisible by 7. 7 times 7 is 49. So right there it makes it composite because I could do 1 times 49 or 7 times 7. So that one is also composite. Let's look at 29. If we were to make a factor tree for 29, all we could come up with is 1 times 29. It's not an even number, so it's not divisible by 2. 9 plus 2 is 11, so it's not divisible by 3. It's not divisible by 5. It doesn't end in 0 or 5. It's not divisible by 6 because it wasn't divisible by 2 or 3. So this number, since the only way we can make it is 1 times the number, is something we would call prime. 64 I know is composite right away because it is an even number greater than 2. So 2 would be a factor. So I could do 1 times 64 and 2 times 32. So right there I have more than one set of factors, so this is composite. Now this even number situation is only true except for the number 2. The number 2 is the only prime number there is that is even. And I know that because the only way to make it is 1 times 2. Every other even number will also have 2 as a factor, so that makes it composite. The number 1 is neither prime nor composite. So what we're looking for is if I can only do 1 times that number as factor pairs, then it's prime. If I can come up with more than one factor pair, then it is composite. I hope these help.